go for the obvious thing first. In number one, when they're asking us to determine if the best fit is linear, exponential, or quadratic, well, C, it's U-shaped, right? So that's our quadratic. We're good to go there. All right. Now, sometimes the rules of the game are what allow you to distinguish one thing from another. If you know one of these is going to be a linear fit and the other is going to be exponential fit, which one do you think is going to be, or which one do you think is more likely to be the linear fit? B. Right? But if you were able to use one, an option more than once, then you might look at this and say, well, yeah, there's a little bit of a curve to it, but is there enough of a curve to it to justify calling it exponential? Maybe, maybe not. But in this case, because we're using each option once, we'll say it's exponential. All right. Now remember, exponential functions could go the other way. They could be increasing. All right. Linear functions could be decreasing. Quadratics could go up and then down. Right. So they could be the reverse of what you see here. So things to keep in mind. All right. There's a mathematical approach that helps us justify our choice, and it has to do with correlation coefficient. So we'll get to that in a minute. But that's going to involve data entry. But more important, and this is something that's often lost, because we want a number to tell us what to do. And that's not always how things play out. Sometimes it's the context of the situation that tells us how things go. So just think of the human growth issue. Like we talked about this like a week ago, maybe a few days ago. The idea that a human, like as their age increases, their height increases, right? But does it increase in a linear fashion?
No, it changes each time.
You're going to be dealing with a rapid rate of growth initially, but then the height is going to level off. So that's not going to be linear, right? Context is going to tell us what we're dealing with, right? Because if it were linear, then that would mean, okay, so let's say when you're, try to get the numbers right here. If you're 7 years old, you're 4 feet tall. All right, so that creates your ratio. Right? So that would mean that if you're 70 years old, you're how many feet tall? If it's linear. 40 feet tall. Does that work? Nah, not in this universe. I mean, it'd be pretty cool. I mean, not practical, though. The food consumption would be off the charts. So, anyway, I mean, Thanos would have to snap his fingers like 30 times. So, anyway, context is going to dictate the situation, all right? Biologists are modeling the number of flu cases as it spreads around a particular city. The total number of cases was recorded, it just sounds awkward, each day after the total reached 16. All right. The data for the first week is shown in the table below. All right. So one thing you might think about, and so this is more for like a science class. Why wait until 16 reported cases? And just really thinking about it, like, are we talking about an outbreak of any kind of virus if there's only 1 or 2 cases? Probably not. Actually, if there's 16 cases, are we talking about an outbreak? Maybe, maybe not. Depends on the city. If there's only like 1,000 people in the city, then maybe. Although I would hesitate to call it a city if there's only 1,000 residents. Right? But you're talking about the measles outbreak in Rockland County. Like all the controversy surrounding that. Like the government, like the mayor. I forget. I read it yesterday, but I can't remember.
Governor.
No, it wasn't the governor. It wasn't the governor. I think it would have to be like the mayor of Nanuet, maybe. But anyway, he said, or he declared a state of emergency, saying that any unvaccinated people basically can't be out in public. You can't go to school. Okay? And so there's pushback saying we have the right to not be vaccinated. And then other people are saying, well, I have the right to not get the measles from your kid. So like there's a big back and forth going on. So what's the right answer? I don't know. I'm not qualified to really judge that sort of thing. But I would guess that there's probably more than 16 cases of the measles in order to declare a state of emergency. All right. So just something to think about. Now, a linear relationship, probably not, right? Because as the days go on, like if we got to, let's say the 10 billionth day, and it's a 1-to-1 relationship, right? So a slope of 1. Could there be 10 billion cases of the measles?
No.
No. Why?
10 billion
Because
people.
there's not that many people.
There are not that many people on the planet. All right. And well, you got to figure potentially, but you got to figure some of these folks are dying off before that happens. So, you know. But yeah, I suppose. Then you get into like overpopulated world. Yeah. So a lot of other variables at play. Yeah. I mean, so it's completely confounded because there's a lot of other variables that come into play that would kind of stifle everything. All right. So, fortunately, in this question, you're not asked to make a determination of the type of relationship, but you could be. I mean, if you flip forward in the packet, you could see there's plenty of instances where it doesn't tell you what kind of model to use, and you have to figure it out. So let's go into stat edit. Let's clear out our data. Remember, if you want to clear out a data set, you go to the column heading and hit clear, and then enter. All right, type in your values: 0, 1, 3, 4, 6, 7.
Yo, you're quick.
Yeah, it's the no-looker approach. All right, so use your calculator to find the exponential regression equation for this data set in the form of y equals a times b to the x power. All right, and then round all coefficients to the nearest hundredth. All right, so we have our data in. Very easy process. Once you have your data in, you go to stat, calc. Well, we used linreg yesterday for linear regression. We're looking for an exponential regression. Well, keep scrolling down till you find the one that seems most appropriate. My guess is it's the exp reg. So hit enter on that one. It's ready to rock and roll. My recommendation, just like yesterday, store it. Store regression in Y1, and again, that's alpha trace. Very good.
Scroll down.
So then calculate. So it gives you the whole shebang. It's asking us for y equals a times b to the x. So they give you the model at the top, which corresponds to that. It's just written in a slightly different form, using the caret instead of actually writing it as an exponent.
Different. Mine says y and then a and then b.
Yeah, I don't have any R's.
Oh. You don't have r squared equals and r equals? Diagnostic on, yeah. Like yesterday when we put our diagnostics on.
No, I didn't have my calculator yesterday. This kid.
Ah, this guy.
How do I do that again?
Mode. You'll see if you scroll all the way down, you'll see the option for stat diagnostic.
Take 2. Thank you, Jake. Stat. Count. Got it. Thank you.
All right, so here's our model. 15.92 times 1.12 to the x power, because they give us the model at the top and then they tell us what the a and b values are. All right. Now, they don't actually ask us for the r value, but the r value here represents the correlation coefficient. Now, the reason you would want to know the r value in some circumstances is to make a distinction between different models. So let's say you tried a linear regression model and came up with an r value of 0.8, and then you try an exponential regression, you come up with an r value of 0.99756, blah, blah, blah. Which is a more appropriate fit? The 0.8 or the 0.9975, blah, blah, blah? The 0.9975, blah, blah, blah. That's the way to go. All right, because that's closer to what? 1. All right, the closer the r value is to 1, the stronger it is. All right, the stronger the relationship is between the two variables. All right, so that's telling us, well, just based off of these numbers, it's telling us that we have a strong relationship, very, very strong, almost perfect relationship between x and y. All right, so it's telling us specifically that there is a relationship between the number of days and the cases of the flu, all right? So there's something to be concerned with here. So based on the regression equation, how many total cases of flu will there be after 2 weeks, all right? So what we're doing there is finding the y value after 14 days. Now, we took that proactive step of storing the regression equation in, all right? So it's in there. So we can go to the table if we want and go down to 14. No algebra required. All right, so we would get 79.845. All right, no rounding instructions given, so you just go 3 decimal places. All right, and don't overthink this stuff, because when you're talking about regression, you're talking about approximate values to begin with. So what does it matter if you round it? These rounding instructions are really just given so that people who grade assessments related to this can take off points when you don't follow instructions. All right, that's really all it comes down to. So before you start saying things like, well, how could you have 0.845 of a person? It's really not that. You got to think of the context of the situation. It's 0.845 of a case. Right? So what would that mean? Is that possible? Maybe, maybe not. Are you a scientist? I don't think so. Not yet.
On my calculator, ask for the table. How do I change it out of that?
Second window and change it to auto. But if it's in ask, just type the 14 in and hit enter.
Hey, when I do the table, it just says error.
When you hit table, it says...
Like with the second graph, you get to the table, it says error.
All right, so another strategy that you could use, if you don't want to use the table approach, would be to hit alpha trace y1 and then type in the 14 in parentheses. That'll get you the value there also. The last strategy, which is my least favorite, would be to plug the 14 in for x here. All right, so you would do 15.92 times 1.12 raised to the 14th power. That's a less accurate answer, but it's fine, I guess. Or 77.803. Now, it's in a math class. I mean, what are we really talking about the difference of? We're talking about a couple units of difference. But in real life, that could be pretty significant, because if you're producing vaccines, doses of vaccine based on your prediction of the number of people who are going to contract this illness, you're going to come up short, right? So here I would say, okay, I better play it safe and get to 80. Here I might say, I better play it safe and get to 78, and now 2 people don't have the vaccination. All right, so that could be a problem. I mean, that will be a problem. All right. According to your model, by what percent are the flu cases increasing on a daily basis? All right, so this goes back to the idea of an exponential function. All right, so it's tying things together from prior units. So we're looking at, just going right back to the exponential unit, the formula being a times p, or equals p times 1 plus r to the t power, where the r represents the rate of increase or decrease. All right, if r is positive, it's increased. If it's negative, it's decreased. So therefore, it's increasing
12%.
at a rate of approximately 12% each day.
This is 1.12, so it's like 1 plus 2.1.
All right. If it were a value less than 1, that would show a decrease, which would mean that the situation is improving, but that's not what's happening here. All right. So 12% increase on a daily basis. All right. So it doesn't take much. You go into your table to see what's going on. After a month, with that rate of increase, you have a little over 550 confirmed cases of the flu. So, you wait, an entire season, 3 months. So let's go 90 days, roughly. All right, so 500,000 people would have it. Right, so a 12% increase doesn't seem like a lot until you start expanding it out that way. Hospital officials will declare an emergency when the total number of cases exceeds 200. On what day will they need to declare this emergency? So that's a case where we know that 200 needs to equal the 15.92 times 1.12 to the x power. All right, so we're really tying it together. All right, really, if you think about the difference between this and the previous unit, or at least the unit involving exponential functions, I don't know, that was 2 units ago? No, actually, I think that was the last unit. The only difference is we're coming up with the equation that we're using before actually having to solve it. All right, we're coming up with it from data, which is kind of cool. Right, because that allows you to collect your own data, come up with these equations, and then draw your own conclusions from it. Right? I see a lot of that with science research. I don't know how many people are going down that road, but that tends to be that particular avenue. So I'm going to do this graphically. All right, I mentioned yesterday that we had the ability to create graphs in our calculator without actually having to create the graph on paper, and then use all the applications of that graph without actually having to do it all out.
Instead of doing all that, can't you just go to the table and look at it where y is 200?
Only if it's exact.
Okay, it's not. It's 200.6.
Yeah, so I want the exact value. All right, so what we do, I still have my plot on from yesterday, but I'm going to turn it off because I know a lot of folks were working on region stuff, and so you would want your plot to be off if you wanted to create a regular graph. So I'm gonna put myself in your position. Your plots are off. I want to find the intersection between my regression model and 200. I want to create a scatter plot to make sure my regression goes through those points. So second, y equals, enter on plot 1, enter on the word on, make sure it's a scatter plot, hit enter on it if it's not, make sure it's L1 and L2 as a default. Once you do that, zoom what?
Zoom.
What topic are we working on?
Stat.
Statistics, yeah, zoom stat. All right. So we have the points that we were given, the curve going through practically all of them, and then the graph stops. All right. So what I want to do is I want to reorient it or reorganize it so that y equals 200 appears. All right. So what I'm going to do is I'll hit window. You'll see that y max is only at 38.23. I need that to be much higher. I'm going to make my y max something like 210. Give it some wiggle room on the high side. And then hit graph. Right? So the zoom stack gets you started. We adjust from there. All right? Now, you can see the horizontal line it now appears. What does that tell me about my x interval? Right? I'm only going out to 7.7. What do you think I ought to be going out to? 20? Try 20? Something bigger, right? That's the idea? We haven't gone out far enough. So let's go further. Not quite there. Give me another number. 30. All right. So we have a clean intersection there. So I want to find the intersection. How do I do that again? Second, trace, option 5. Get as close as you're willing to get to the intersection. Hit enter 3 times. And you're going to get x is approximately 21.973 days. All right. So we got to think about in what day that would happen, because it says on what day. That would be the 22nd day. All right. Now, it all depends on what kind of problem it is, what kind of work you have to show. If it's a multiple choice question, you can get that answer right from the table. If you have to show some work, the table's not going to cut it. You need to show something other than just, I got it from the table. All right. So this is the way to go. So let's say you didn't want to use the intersection function, or maybe you did, but you couldn't figure out the window. What's another way that you could figure out the solution? There's another feature in the calculator that we used in that unit. Solver, yeah. So math, go to solver. I need to change my mode. Oh wait, no, I'm in the right mode. That's weird. I just gotta fix my stuff because I changed it for a different class. Yeah, so you have some value in there. All you have to do is hit alpha enter, and it'll drag you to the solution, which is 21.973. All right, so you can get it that way also. And this is the last one. Well, it's obviously the last one we'll do. They got it. The cost per widget produced by a factory generally drops as more are produced, but then starts to rise again due to overtime costs and wear on the equipment. Quality control engineers recorded data on the cost per widget compared to the number of widgets produced. Their data is shown below. The number of widgets and the cost per widget. All right, so here they're asking us to describe why a quadratic would be the most appropriate approach. All right. A widget is kind of a weird term. It's related to a business. So in like a business class, instead of coming up with a new fictitious object or item that's in production in a factory or whatever, for every single problem, they just use widgets, and the word widget just represents some fictitious object that's being produced. Right, so they don't have to say like, pecan sandies or bottles of Tab or Tang. Oh, I didn't know Tang still existed, by the way. Fun fact of the day. It's like a not quite as good high C. But they have the concentrated solution now for that stuff. You just put like a little eye drop amount into a water bottle, and now you got a whole water bottle filled with Tang. Tasty 80s. That and Polio string cheese.
Oh, Polio string cheese is the best.
Those were big back in the day.
So good.
The commercials were off the hook. All right, so data's in.
Go to quadratic something.
Well, not even going to do that yet.
Okay.
I'm going to go into y equals because this stuff is irrelevant now because it's related to the last question. I'm going to clear that out. Plot 1 is still set up for a scatter plot, but the window is set up for the last question. How do you think I can get a new window that's particular to this data? Zoom. Not standard. What topic are we working on? Stat.
Wait, so how do we know when to take like the plot one off when we're not making a?
When you're not making a stat plot. Yeah. All right. So when you're creating this graph, if you're doing it by hand or if you're doing it on the calculator, you should end up with something that looks kind of like this. And it doesn't have to be pretty. I mean, my answer, I'm kind of a wise guy when it comes to stuff like this. On a test, I would be like, the answer to this is because my data looks like that. Right? But you should probably be a little bit more elaborate in your answer. Data looks parabolic or looks like a parabola when plotted.
Like you can answer like that.
Yeah. That's the thing. The first thing that you should do is take a look at the picture and see what the most appropriate model is. If it looks linear, if it looks quadratic, if it looks exponential, then that kind of steers you in the right direction. Use your calculator to find the quadratic regression equation for this data set in the form of meh, and then round all your coefficients to the nearest thousand. So what do you think I'm going to do? You just tell me. What button should I press? Stat, calc, quadratic, yeah.
That's what I said.
We're ready to rock and roll here. Now, we don't actually have to do anything else after we set up this equation. We don't have to use it to solve for anything. So if you wanted to ignore the store regression equation in this particular problem, you could. But if you want to build up a little muscle memory, you might as well just throw it in. Alpha trace, just a good habit to get into, even though you don't need it in this particular case. Calculate. It's kind of the thing where if you convince yourself that it's a necessary step in all cases, then you're less likely to forget it when you need it. Right? So you just gotta kind of have to lie to yourself a little bit. Nearest thousandth, so 0.001. You see, they give you the model at the top, and then they tell you what the A, B, and C values are. So minus point. Oh, I forgot my x squared. Minus 0.250x. All right, it's annoying, but they said nearest thousandth, so 3 decimal places. So if you wrote negative 0.25, you're not going to be happy with me when I take off half a point, but you really didn't follow the instructions, and so I have to. All right, plus 16.863. And there it is.